Dear students, how are you? Well, we have started a new chapter that's called chapter 6, Effect of Heat on Matter. Well, this is a very interesting chapter and kind of vast one. But I hope if you just listen and carefully to my video and try to realize it by own, it won't be a very hard for you after all. Well, our first topic is heat and temperature. So, what is heat? Heat. Heat is an energy which gives us the sensation of hotness or coldness. Okay, hotness or coldness is a physical property of this energy somehow. Okay, well, we know sometimes that if we can apply heat in a substance, the substance internal molecule excited and it vibrates most frequently, and finally it becomes solid to liquid and liquid to gas. Well, something this it and this even occurs for kinetic energy, because kinetic energy inside the atoms will responsible to separate those things, and the kinetic energy is related to the heat energy directly. Okay, then comes temperature. While temperature is a natural phenomenon, is a natural phenomenon which tells us the direction of heat flow, or in which direction heat will travel at higher to lower temperature. Okay, heat flow. Heat denoted by Q, and temperature denoted by T. Unit of heat is joule, and unit of temperature is Kelvin. Okay, this is SI units of all those. Now come to a second point, is called internal energy. Sorry, internal energy. Okay, if we accept heat as energy, at the same time we have to know how heat energy is transferred from one place to another place. Generally, We think that energy always flows from higher energy to lower energy. The amount of a small hot pin, but if you put a pin into the water, a small amount of energy of, of the pin will transfer to the water of the glass. Okay? The fluency of the heat from one place to another place is called temperature. It is embedded in our daily life very much, or we always say temperature, always tell temperature like this or that. So it's very important to understand. So a discussion or an example of how heat transfer from one place to another place. Like like we take a bucket, two columns of bucket, and I fill up with water, and there is a valve that maintains the channel to water flow. Well, what will happen then? If the highest of the upper surface of the water in the two columns are different and they are connected to the pipe, the flow of water will not be determined by the which container contains more or less water. Water flow will depends on the highest of the upper surface of the water of the container. Always water will flow from higher and highest to lower highest until the two highest become equal. This is how we can compare how heat flows from one place to another place. The heat flows until there is a variation of temperature. When temperature is same, the flow of heat stops. Now we come thermal property of matter. To measure the temperature, the specific property of a specific substance are used. The property of a substance will change with temperature, and measuring the change actually accurately, the temperature can be measured. It is called thermal property. Okay, it is called thermal property. The property of a substance which is used to measure the temperature is called thermometric property. Property, okay, I write the property of a substance, the property of a substance which is used to measure the temperature where the temperature is called thermometric property. Okay, there is many types of thermometer. One is mercury thermometer, another is alcohol thermometer. In alcohol thermometer, alcohol is used inside to measure for thermometric element, and to as market thermometer, the mercury is used as a thermometric element or substance. Like in a gas thermometer, gas is thermometric substance, and the pressure of the gas at constant volume is the thermometric property. As the resistance of a metal changes with temperature, so the resistance is is used the thermometric property. Different thermometric substances are effective at different temperatures. So to measure the very high or very low temperature, the specific thermometric property of a specific thermometric substance has to be used. Copper and constant metals are used as thermometric substance. If two junctions of different metals are kept at different temperature, it produces an EMF, and by measuring this, the temperature can be calculated. The thermocouple is used to use industry on a long scale because it can measure the temperature from minus 200 degrees Celsius to 1000 degrees Celsius. That's a huge fluctuation. Okay. Although we use meter thermometer and scale, we use Celsius scale of temperature in our daily lives. It international unit is Kelvin. Adding 273.15 degrees Celsius, the reading of Celsius becomes Kelvin scale reading. Now we will discuss something or some topic that can relate us the relation between various scales. There are three thermometers, and the meant to measure something that is same for all. Well, in this scenario, we see a thing. Celsius is 0 degrees Celsius, as Kelvin is 273, and for a 32.32 degree F. Okay, and that point 100 degrees Celsius, 373 Kelvin, and 212 degree Fahrenheit. So we can make a relation between them. See, C minus 0, 100 minus 0 equal to F minus 32, 212 minus 32 equal to K minus 273 by 373 minus 273. You see here, in all of these cases, in Celsius scale, the temperature we want to know, and the lower point of melting point, then upper point of vaporization minus lower point of melting, same as that. So we calibrate here, we see something like that: C by 5, F minus 32 by 9, K minus 273 by 5. And there's the calibration here. You can simply convert it from Celsius to Kelvin like that way. See here, C by 5 equal to K minus 273 by 5. So if we vanish those 5, K is equal to C plus 2723. That's how we can convert it from Celsius to Kelvin scale. Now a relevant math. Wait. Question. The temperature at London is 96 degree Fahrenheit. 8 into Celsius and Kelvin. Well, we know C by 5 equal to F minus 32 by 9. So F is given 96 degree Fahrenheit. So 9C equal to 5F minus 32 into 5. So C is equal to 5 into 96 minus 32 into 5, 160. Right? 9. 5 minus 9, 5 by 8 by 96 minus 160 divided by 9. So 35.55 degree Celsius is the value of C. Now K is equal to, you have told you, C plus 273. So 35.55 plus 273 plus 273. K is equal to 308.55 degree Kelvin. So that's how we do the math. And other at which temperature the reading of Celsius and Fahrenheit scale are equal? At which temperature? At which temperature the reading in and Fahrenheit are equal. Well, we know C by 5 equal to F minus 32 by 9. Okay. C equal to F equal to X. Let as the same. X by 5 equal to X minus 32 by 9. 9x equal to 5x minus 160. 4x equal to 1 minus 160. then x equal to minus 40. Per degree. And that's another one. This is the temperature where both is equal. Not Celsius and also 40 degree Fahrenheit. Okay. Same. Another question. What is the temperature in Celsius? What is the temperature in Kelvin if a healthy body is 90.4 degree Fahrenheit? This is your HW. You better try it and let me know you have done it. Okay. So that's all for today. Tomorrow we'll discuss a very important topic regarding this chapter. Okay. Till then, be safe. Allah Hafiz.